Picture this. You're out on the open water. The coastline has, completely faded away into this thin blue line.
Yeah, it's just you, the horizon, and maybe the steady hum of the diesel engine.
Right. You are completely self-reliant. You're carrying your own power, your own shelter, your own fuel. It's basically the ultimate dream of freedom.
It really is, until nature calls.
Exactly, because your comfort, your sanity, and honestly the sheer physical habitability of your vessel, it all depends entirely on one of the most overlooked, decidedly unglamorous aspects of marine engineering. We were talking about the plumbing.
Oh, absolutely. It
Right.
truly is the great equalizer of boat ownership.
Yeah.
Oh, yeah. I mean, you can spend an absolute fortune on the most advanced radar, or like you can have teak decks in these luxury cabins. But if your sanitary system fails,
It's game over.
it is. Your multi-million-dollar yacht instantaneously transforms into, well, an uninhabitable floating prison. Everything else just completely stops mattering the second the plumbing stops working.
Which is why today our mission is to extract the engineering secrets from a document you would normally only read in a state of sheer panic.
The installation manual.
The installation and equipment guide for the Jabsco Electric Marine Toilet. We're going to dive into exactly how this system works and why it's such a massive upgrade from traditional marine setups.
And really, what managing a closed-loop sanitary system can teach us about resourcefulness, right? And engineering. And maybe even our own daily lives.
Okay, let's unpack this, because if you have ever used a traditional manual marine toilet, you know it is basically like churning your own butter.
That is a very visceral, painfully accurate comparison. Anyone who spent time offshore knows exactly what you mean. The manual head is just, it's an exercise in endurance.
You do your business, and then you have to stand there in this tiny swaying fiberglass cubicle and manually pump this heavy spring-loaded handle back and forth.
Over and over again.
Over and over. You are essentially acting as the mechanical force, pushing water and waste through this complex series of tubes using nothing but your own upper body strength.
It's exhausting.
It really is. And if you happen to invite guests on board, like people who aren't seasoned sailors, you practically have to give them a mandatory 10-minute training seminar just so they can use the restroom without breaking something.
Which, doesn't exactly scream luxury or high-end hospitality.
Not at all.
But moving past that manual pump, it isn't just about bathroom convenience. It's really about fundamentally upgrading the vessel's entire ecological management.
Okay, so replacing the grueling manual labor.
Right. We're looking at the electric alternative today, which replaces that with push-button convenience. It runs efficiently off a standard 12-volt battery system. It just changes the entire experience of living on the water because you're integrating heavy-duty machinery into the process.
Let's get into the anatomy of that machinery, actually, because, you can't just take a porcelain household toilet, glue it to a boat deck, and call it a day.
No, definitely not. Household plumbing relies entirely on gravity.
Right. And on a boat, you are often sitting at or even below the waterline. Gravity is not going to help you push waste out. Moving from manual to electric requires some serious active engineering.
It does, and the guide highlights two specific components that make this electric leap possible. You have the self-priming flush pump, and you have the macerator.
Let's start with the pump.
So the self-priming aspect is crucial. Because you are fighting against the natural water level outside the boat, the system has to generate its own suction.
It can't just rely on water falling.
Exactly. A self-priming pump creates this powerful internal vacuum. It forcefully pulls water up into the bowl while simultaneously pushing the waste out and up into the holding tank.
So it completely removes gravity from the equation.
Right, substituting it with sheer mechanical force.
And then once that waste is actually moving, it hits the macerator. From reading the guide, this thing sounds like an absolute beast. It's essentially a heavy-duty blender, right? Just integrated directly into the plumbing lines.
A blender is the perfect way to visualize it, honestly. In a traditional manual system, whatever goes down the bowl stays in that exact physical state as it travels through the pipes.
Which drops straight into the holding tank.
Yeah. But an electric system with a macerator actively grinds everything down into a really fine slurry before it ever leaves the immediate vicinity of the toilet.
Which, according to the source material, is highly critical because it saves space. And I mean, anyone who has spent more than an hour on a boat knows that space is basically the most valuable currency you have.
Every square inch is accounted for.
Yeah, it absolutely saves holding tank space.
It does. But the secondary benefits of that slurry are arguably even more important. By grinding down the solid matter, You are exponentially increasing the surface area of the waste.
Oh, interesting. So what does that actually do?
Well, it allows the natural biological breakdown processes inside the holding tank to happen much faster and much more efficiently, which, as a direct result, drastically reduces lingering odors.
Okay, that makes sense. Odor control is huge.
It is. Furthermore, it changes the physical architecture of your boat. Think about it. When you are moving a fine liquid slurry instead of, solid waste, you can use narrower, much more flexible hoses to route the plumbing.
Oh, right. Snaking stiff, wide diameter pipes through all those tight bulkheads and hidden compartments of a boat hull. I mean, that sounds like a builder's nightmare.
It is a nightmare. So the macerator allows for a much more elegant hidden installation.
I noticed the guide also specifically mentions a model called the Quiet Flush E2, which tells me, kind of reading between the lines here, that earlier electric models must have sounded like a jet engine taking off inside your bathroom.
Oh, they were notoriously deafening. You have to remember the environment we're talking about. You're operating a high-speed metal grinder and a powerful mechanical water pump inside a tiny, enclosed fiberglass box.
Right, and fiberglass is practically an echo chamber.
Exactly. It used to be a given that if someone flushed an electric head in the middle of the night, the vibration and noise would just wake up every single person sleeping on the boat.
Not ideal.
No. But the Quiet Flush E2 models solve that acoustic nightmare by physically separating the water intake pump from the discharge pump. It dampens those jarring plumbing noises and totally isolates the vibration.
Okay, so I hear all of this. The push-button convenience, the macerator turning everything into a manageable slurry, the quiet operation. But I have to play devil's advocate here and push back for a second.
Sure, go for it.
A manual toilet is significantly cheaper up front, and honestly, more importantly, it has almost no complex moving parts.
True.
So if I'm 50 miles from shore, just plunging through heavy seas, shouldn't I prioritize the simple, purely mechanical, hand-operated setup over a complex electrical appliance? Like, what happens if my battery bank dies or a wire shorts out? I'm completely stuck, right?
What's fascinating here is how we calculate risk in isolated environments. You make a good point. While the manual system is indeed simpler mechanically, the electric system, specifically because of features like the macerator, drastically improves the long-term health of the boat's infrastructure. Well, a manual pump will never blow an electrical fuse. That's absolutely true. But it is infinitely more likely to cause a catastrophic physical clog deep inside your holding tank lines. Because, as we said, the waste isn't being broken down prior to transit.
Ah, okay. I see the logic now. You are essentially trading electrical risk for plumbing risk.
Precisely. And anyone who has had to dismantle a sewage pipe in the cramped bilge of a boat while underway will tell you that a plumbing clog is a nightmare scenario you want to avoid at all costs.
I can only imagine.
Yeah, fixing a blown fuse or tracing a wire is infinitely preferable to that. Furthermore, the installation guide emphasizes that these modern electric systems have incredibly robust built-in safety features.
Right, you aren't just hooking raw wires directly to a battery terminal.
Exactly. The installation protocol mandates the use of properly sized circuit breakers and careful voltage calculations to ensure the motors are fully protected from overloading.
So it's a calculated risk, but one that's mitigated by flawless installation. Speaking of installation, once you've got the physical hardware bolted to the floor, the guide moves into what seems like the most critical and highly debated decision a boat owner has to make. It kind of dictates the entire chemistry of the system.
Ah, yes. What type of water are you actually going to use to flush?
The great divide in marine plumbing, raw water versus fresh water.
It is quite the debate.
The guide lays out the parameters. So raw water means you are dropping an intake hose and pulling water directly from whatever sea, lake, or river you happen to be floating on.
Right. It's free and it's infinitely abundant.
But the guide notes it requires, quote, specific vented loops to prevent flooding, and it causes massive long-term maintenance issues.
Which we will definitely get into.
Yes. And then on the other hand, fresh water tacks into the boat's own internal potable water tanks. It keeps the bowl much cleaner and is highly recommended for inland boating. But here's where it gets really interesting for me.
Yeah.
Choosing between raw and fresh water feels like this crazy psychological test. It's like deciding between foraging for wild, unpredictable berries in the forest versus choosing to eat exclusively from your own highly limited emergency bunker pantry.
That is a great analogy.
Right. I mean, if I'm floating on a literal ocean of water, wouldn't I be absolutely crazy to flush away my precious drinking supply?
It feels Completely counterintuitive. Your deepest survival instinct tells you to hoard your fresh water. Why waste the most vital resource on a boat just to flush a toilet when there are millions of gallons of water right outside the hull?
Exactly.
But if we look at the chemistry, the biology, and the physics of what actually happens inside those pipes, the freshwater choice becomes an entirely logical protective measure.
Okay, I need you to break that down for me. Let's start with the physics. The guide mentions vented loops if you use raw water. What are those and why do I even need them?
So if you pull raw water from the ocean, your intake hose goes from a hole in the bottom of the hull up into the toilet and back down into a holding tank.
Okay, tracking with you.
Physics dictates that water always seeks its own level. If the toilet is below the waterline, the ocean desperately wants to flow inside to equalize the pressure.
Right.
A vented loop is essentially a high arch in the plumbing hose with a tiny specialized air valve at the top. If you don't have it, the water flowing out can create a vacuum.
Oh boy.
Yeah, acting like a giant continuous straw that siphons the ocean directly into your boat.
Meaning you flush the toilet, create a vacuum, and the ocean just keeps pouring in until the boat sinks. That is terrifying.
Very terrifying.
Yeah.
But a simple air valve breaks that vacuum siphon. So raw water introduces the physics risk of sinking.
Which is bad enough.
Right, but the biological risk is arguably even worse.
How so?
Seawater isn't just water, it's alive. It's teeming with microscopic life like plankton, algae, various bacteria.
Right, the ocean is basically a soup.
Exactly. So when you pull that raw seawater into your boat's plumbing to flush the toilet, some of that water inevitably sits idle in the intake lines and the rim of the bowl between flushes.
In a totally dark environment without any circulating oxygen.
Exactly. In that dark, airless, stagnant environment, all that microscopic marine life quickly dies. And as soon as it dies, anaerobic bacteria take over to break down the organic matter.
Oh, I see where this is going.
Yeah. The primary byproduct of that specific bacterial decomposition is hydrogen sulfide gas.
Which produces that unmistakable rotten egg smell.
That is the infamous, dreaded marine toilet smell. People often assume their holding tank is leaking waste, but 9 times out of 10, it's actually decaying marine life trapped inside the intake pipes before the water even reaches the bowl.
That is wild.
And on top of the smell, if you are operating in salt water, you have a chemical reaction to deal with. The salt in the raw ocean water reacts directly with the uric acid in human waste.
To do what?
It forms a rock-hard calcification on the inner walls of the hoses. It literally narrows the arteries of your plumbing over time, creating complete blockages.
So by using fresh water, you aren't just seeking convenience, you are actively engaging in preventative maintenance.
Absolutely.
You avoid the biological decay, you stop the chemical calcification, and you don't have to worry about back-siphoning the ocean into your cabin.
For many boaters, sacrificing a few gallons of fresh drinking water from their tanks is a perfectly acceptable trade-off to keep the boat smelling clean, protect the hoses from turning to stone, and keep the entire system functioning smoothly.
It's not just a choice of water, it's a choice of which chemical ecosystem you want to manage.
That's a great way to put it.
So we've got our macerator grinding things into a slurry. We've made our calculated choice on the fresh water supply. Now we have to zoom in on the specific hardware features that keep this whole delicate balance from catastrophically backfiring.
Right.
And the source material highlights 2 incredibly vital components here. First, something called the joker valve, and second, the light flush option. Let's start with the joker valve, because I'm picturing the physics of this environment. You have a holding tank full of liquid waste and a boat that is violently pitching, rolling, and slamming into waves. What is stopping that sloshing tank from just burping right back up into the toilet bowl?
That is exactly the problem the joker valve solves. It is arguably the most important piece of rubber on the entire vessel. It sits at the discharge point, linked directly to the output tube.
I was actually looking at the technical diagrams of this thing. It looks like a rubber duck's beak.
Yes.
It's basically a one-way VIP bouncer at a nightclub. The pressure from the flush pump forces the rubber lips open to let the waste out into the holding tank, but the second that pressure stops, the lips snap shut.
Instantly.
It absolutely refuses to let anything flow backward. Not liquid, and especially not the pressurized gases and bad smells from the tank.
If we connect this to the bigger picture, the joker valve is a textbook example of a single point of failure in engineering. I mean, think about the hostility of the environment you just described. The holding tank is full of sloshing liquid and expanding methane gases. The only thing standing between that toxic pressurized environment And the pleasant, habitable cabin where you're trying to eat dinner is that one little rubber seal.
That is a lot of responsibility for a 2-inch piece of rubber.
It really is.
Yeah.
And it highlights exactly why the guide stresses that the valve must be inspected regularly and why routine maintenance is not optional.
Because rubber degrades.
Exactly. Rubber degrades in harsh chemical environments. Over time, it gets stiff, the lips warp, or the edges get blocked by microscopic calcium buildup. If that rubber bouncer gets stiff and falls asleep on the job, leaving even a millimeter gap, the pressure from the holding tank pushes liquid and gas right back up into the bowl.
I am mentally adding inspect Joker valve to my daily survival checklist.
Highly recommended.
Now, alongside that crucial defensive valve, the guide heavily promotes the light flush option. This is a low-volume control setting designed to conserve liquid and electrical energy. It runs on a high-torque pump motor, but uses a smart, user-friendly control panel to just sip water instead of gulping it down like a standard flush.
This circles right back to our freshwater debate. If you make the choice to use your onboard, limited potable water to flush the toilet, you need to be incredibly efficient about how you deploy it.
Right, you can't use 2 gallons of flush like you do at home.
Exactly. The light flush system is an elegant engineering solution to that problem. By optimizing the physical water pressure and utilizing that strong, precise pump motor, it can clear the bowl effectively, using a tiny fraction of the liquid.
And less fresh liquid going into the bowl means less liquid rapidly filling up the waste holding tank.
Which extends the time you can spend out on the water before needing to divert your trip, find a marina, and pump out the holding tank.
Right. Nobody wants to cut a trip short for that.
But there is another much more subtle benefit here. Weight management. Water is heavy. It weighs roughly 8 pounds per gallon.
Oh, wow.
Yeah. A holding tank full of unnecessary flush water adds hundreds of pounds of useless weight to the boat. That extra weight pushes the hull deeper into the water, increasing drag.
And that affects performance.
Directly. It negatively affects the vessel's top speed, its handling characteristics, and its overall fuel efficiency.
So by utilizing a low-volume light flush, you aren't just saving drinking water, you're actively managing the overall weight distribution and performance of the boat. It really is a deeply interconnected ecosystem.
It really is.
Every single time you push that flush button, it slightly alters the fuel economy of the diesel engine. That is wild to think about.
Everything is connected on a boat.
But of course, none of this intricate ecosystem works if you don't install it right and maintain it properly. Which brings us to the wrench work. The guide transitions from all this theoretical engineering into the gritty, practical reality of maintaining the system without inadvertently sinking your own ship.
Safety and methodical procedure are the absolute first priorities here. The installation manual is exceptionally clear in the protocol before you even pick up a single tool.
The pre-installation steps are intense. Disconnect the holding tank to relieve pressure. Turn off the main battery power so you don't get electrocuted in a wet environment.
Standard precautions, but vital.
Wear thick gloves. Use shatterproof eye protection for drilling through fiberglass. And crucial, above all else, check the C-Tox before handling any hoses.
Yes. For anyone who might not be familiar with marine terminology, a seacock is a heavy-duty mechanical valve physically bolted to a hole in the hull of the boat. It lets water in from the ocean or out into it.
Right.
If you disconnect an intake plumbing hose to attach your new electric toilet without manually closing that seacock first, you have just opened a direct, unregulated hole to the ocean.
And that is bad.
Very bad. The pressure of the sea will begin violently filling your bilge with water immediately.
So triple check that the seacock is closed. Understood. Now, for the tools themselves, the guide lists screwdrivers, heavy wrenches, and stainless steel hose clamps, which is exactly what you'd expect for plumbing.
Yes, standard plumbing tools.
But it also explicitly lists a digital multimeter for electrical checks. Why does a plumber need a multimeter?
Because it's a 12-volt direct current system. In a standard house on land, you plug an appliance into the wall, and you generally trust the grid is delivering a stable 120 volts.
Right, you don't even think about it.
On a boat, power has to travel from the battery banks through copper wires that might be snaking 30 or 40 feet through the hull to reach the bathroom. In a 12-volt system, distance is your enemy.
I see.
If those wires are too long or the wire gauge is too thin, electrical resistance causes the voltage to drop significantly by the time it reaches the toilet.
So the pump might only be receiving like 10.5 volts instead of 12.
Precisely. And here is the engineering reality. The macerator motor requires a specific amount of power watts to do the physical work of grinding. If the voltage drops due to long, thin wires, The motor is forced to pull significantly more amps to compensate and achieve that same power.
And more amps means?
Pushing higher amps through a wire creates heat. If a motor struggles and overheats, the internal components melt, the wire insulation can catch fire, and the motor burns out prematurely. The multimeter ensures your electrical foundation has minimal voltage drop before you ever push the flush button.
That makes perfect sense. You're ensuring the mechanical beast actually has the clean energy it needs to function.
Exactly.
Okay, so you've measured your voltage, clamped your hoses, and got it installed safely. Now you have to live with it. The ongoing maintenance protocol in the guide is pretty specific. Wipe the spinning motor elements often to prevent corrosion, grease the control mechanism, routinely check the rubber seals for stiffness or wear.
Basic upkeep, but essential.
But there was one piece of maintenance advice that really stood out to me. It instructs the user to regularly flush the lines with a white vinegar solution.
Yes.
I'm trying to picture the chemistry here. Flushing vinegar through the lines. Is that essentially like doing a preventative arterial cleanse for the boat's plumbing?
An arterial cleanse is the perfect analogy. We discussed earlier how the chemical combination of salt and uric acid forms rock-hard calcium deposits inside the hoses.
The calcification.
Right. Over time, a smooth 1-inch hose can accumulate so much calcification that the opening narrows down to the width of a pencil. White vinegar is a mild natural acid. By regularly flushing it through the system and letting it sit in the low points of the hoses, it gently dissolves that calcification.
Oh, wow.
Yeah, it safely breaks down the chemical buildup, keeping the arteries wide open and ensuring the waste slurry can flow freely without straining the pump motor.
It's quite literally preventative medicine for your toilet.
It is. And the guide makes a crucial underlying point here that transcends just basic boat maintenance. On a vessel, out on the open water, maintenance is survival.
Right.
When you smell a faint odor, or you hear a strange, struggling whine from the pump motor, it isn't just a minor annoyance that you can ignore. It is a vital diagnostic indicator. A smell isn't just a smell, it's a warning siren that a joker valve is losing its elasticity or a line is beginning to calcify.
And ignoring it doesn't mean the problem goes away.
No, it means you are inching closer to a catastrophic, unfixable failure.
Because you can't just pick up the phone and call an emergency plumber when you're 3 days out at sea. You are the plumber, you are the electrical engineer, you are the captain, you are completely on your own.
You have to cultivate a mindset of acute mechanical awareness. You have to listen to the machine, understand its chemistry, and respect its boundaries.
So what does this all mean? We started this conversation talking about the simple act of going to the bathroom, and suddenly we are dissecting fluid dynamics, biological decay, and survival mechanics.
It's quite the journey.
It is. We've journeyed from the back-breaking, butter-churning labor of hand pumping to the automated push-button efficiency of high-torque macerators. We've debated the microscopic biological hazards of raw seawater versus the clean, calculated, fuel-efficient use of a freshwater loop.
Yep.
We've looked at the heroic, unyielding rubber joker valves standing guard against the toxic abyss of the holding tank, and we've broken down the careful, highly methodical wrench and multimeter work required to keep the whole fragile ecosystem afloat.
And stepping back, it paints a beautifully clear picture of exactly what it takes to thrive in an isolated, unforgiving environment.
It really does, because even if you, listening to this right now, never stepped foot on a boat in your entire life, understanding how to manage strictly limited resources, how to balance electrical power loads against mechanical work, and how to rigorously maintain a closed ecosystem is a fascinating masterclass in self-sufficiency. It teaches you to look at the engineered systems around you not as magic, invisible boxes that just miraculously work, but as delicate, interconnected balances of cause and effect. You don't just flush a button and forget about it. You understand the mechanics of the disappearance. You understand the physics of your own comfort.
This raises an important question, though, doesn't it?
What's that?
We've spent all this time talking about the hidden mechanics of this marine sanitary system. But these principles of engineering and maintenance apply everywhere. Think about the metaphorical joker valves in your own life, in your career, or in your relationships.
Oh, that's interesting.
What are those small, unglamorous, one-way boundaries you've meticulously set up to keep toxicity out? The routines or the hard lines you've drawn to keep the bad elements from flowing backward and to keep your daily ecosystem running smoothly.
Oh, I love that framing, the hidden boundaries we rely on.
Right. And more importantly, when was the last time you actually stopped and checked them for wear and tear? Because as we've learned today, simply ignoring a failing boundary doesn't fix it.
No, it just means you're going to be dealing with a much, much bigger, more catastrophic mess later on. So keep an eye on your gauges, maintain your boundaries, run a little vinegar through your systems every now and then, and remember, out there on the open water, whether literal or metaphorical, your comfort always depends entirely on the systems you build and maintain. Keep your plumbing clear, and we'll catch you on the next deep dive.